All right, so this is a continuation of trig, right? 6.3. This is trig identities. All right, this is what we need to when we get into proofs. And I assure you that I will make it as simple as possible. But we're going to use these trig identities to prove different statements, okay? So the first is the reciprocal identities, which you already know, right? What is the reciprocal of cosecant? Sine, right? So if it's the reciprocal, then cosecant is going to equal 1 over sine of theta. Right? Nice and easy. Cosecant, or no, we already did cosecant. Secant of theta is 1 over what? Cosine, right? And then cotangent of theta, 1 over tangent of theta, right? Now, really quick, these next two is going to be built off of this right triangle here. Okay. You know that this is my y value. You know that this is my x value and this is my r value, correct? Yeah. So tangent equals y over x, right? X or opposite over adjacent. Okay. Sine of this angle theta, I should put theta here as well, is equal to y over r. Cosine of theta is equal to x over r, right? Yeah, we all know that, correct? Now, can you guys come up with some way to use sine and cosine to make it equal to tangent? Maybe. I like it. Yeah, repeat the question. Can you guys use sine and cosine, right? Figure out a way to make it equal to tangent. Or another way to think about it is, how can I use y over r and x over r to make it equal y over x? Well, if you want to make it on the bottom, right? If you want to flip it, then what are we doing when we flip? What operation are we doing when we flip fractions? Huh? Reciprocal, yes, but not multiplication. Division, right? So if I say, wait, y over x, which is tangent, is going to equal y over r divided by x over r. Can I say that? Because if I divide these guys out, the second one here, that's going to be y over r times r over x, correct? Yeah, because you take the reciprocal, right? We flip it. And then here, we can see that the r's cancel out, and we're left with y over x. Yeah? That makes sense? So if I turn, going back to our beginning of the equation, if I turn y over x into these trig functions and y over r and x over r into these functions here, tangent of theta, or whatever the angle may be, is going to equal y over r, which is sine over cosine. You guys see that? Yeah. So that's one of my trig identities as well. Okay. So I can put here that tangent of theta is going to equal sine of theta over cosine of theta. And if now tangent equals sine over cosine, then cotangent of theta is going to equal what? Take the reciprocal of that cosine over cosine, which is cosine over sine. Okay. Those are your reciprocal identities. These, what, 5? 5. Okay. Any questions on these? No? Okay. Now the Pythagorean identities. When I say the word, or when you see the word Pythagorean, what do you guys think of? Huh? Pythagorean theorem, right? Yeah. Pythagorean theorem that's based off of the right triangle, right? So I drew a right triangle here. Remember opposite, adjacent, and hypotenuse became y, x, and r, right? So the Pythagorean theorem, what is the Pythagorean theorem? Anybody? Huh? Yeah, everybody knows that, right? It's a squared plus b squared equals c squared, right? So the Pythagorean theorem is a squared plus b squared equals c squared, correct? Yeah. And if I have this as my right triangle, can I change my a, b, and c to x, y, and r? Yes? What's the important piece that I need to do in order for me to change it? Can I just put x, y, and r anywhere that I want? No. What's the one rule that I have to keep? The longest side is what? R, right? And the longest side here has to be C, right? So this has to be R squared. And then the X and the Y can literally be A and the B. It doesn't really matter, right? Here, I want to put Y squared first. Okay. So here is my Pythagorean theorem in terms of X, Y, and R. Make sense? Right? Okay. Now the Pythagorean identities that we have up here is based off of this x squared or y squared plus x squared equals r squared. Okay. And what we're going to do with that, so it's based off of, again, y squared plus x squared equals r squared. And how we're going to get our Pythagorean identities is essentially there's 3 of them. Okay, there's 3 Pythagorean identities. And what we're going to do is we're going to divide each one by r squared the first time, and then y squared the next time, and then x squared the next time. Okay, so that's 3 times, right? Yeah. Essentially making one of these guys equal to 1. All right. So the first one, I'm just going to divide all of them by r squared. Okay. Okay, so if I divide r squared by r squared, that equals 1, correct? Yeah. Y squared over r squared, I can rewrite that as y over r quantity squared, right? Yeah. Plus, I can rewrite the x over r, or x squared over r squared, as x over r quantity squared. right? I can say that. Okay. What is y over r? No, what is y over r? Cosine or sine? Opposite, right? Over hypotenuse, right? Which is sine. So I'm going to put sine squared theta. What is x over r? Cosine. Cosine squared theta equals 1. This is your first Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. Okay? All right? You guys understand the activity? Okay. So I'm going to start off with my green again. Let's put it here. Y squared plus x squared equals r squared. Now, since I divided by r squared the first time, I'm going to divide this one by y squared. Okay? Essentially making y squared divided by y squared equal to 1. And again, I'm going to rewrite this guy, x squared over y squared, into x over y quantity squared. Yeah. And then r squared over y squared, that's r over y quantity squared. So this is 1 plus what's x over y? Cotangent, right? Cotangent squared theta equals what's r over y? It is hypotenuse over opposite. Do you guys want to think it that way? Cosecant. Okay? That makes sense? So this is my second Pythagorean identity. Okay? And my last one, I'm going to put it here. Y squared plus x squared equals r squared. I divided it by r squared. I divided it by y squared. Only thing that's left over is x squared. Yeah. So then I know that x squared over x squared is 1. Plus rewrite this guy as y over x squared. R, and then this guy as r over x squared. What is y over x? Tangent. So tangent squared theta plus 1 equals r over x. Secant. Okay. So there are my 3 Pythagorean identities. Okay. You don't have to memorize this. You could just quickly do this activity to get it. Okay. That makes sense? Questions on these 3? Shoot. Whatever your tangent is, we're going to square that number. Yeah. Yeah. Okay. You can think of it like that too. Tan theta squared. Tangent. Whatever tangent of theta is, we're just going to square that number. Okay. All right. Cool. Okay. Now I want to do this. Find the values of the trig functions of theta, all 6 of them, from the given information. So you're given some information here that sine of theta is -4/5 in the 4th quadrant, right? whenever we have these problems in this section, right, of this trig section that we're on, my first instinct is to draw that reference triangle, right? We talked about reference triangles. So draw that reference triangle, and it's in the quadrant 4. Remember my quadrants? Yeah. So make a makeshift, and this would be my reference triangle in my 4th quadrant, right? Remember that this is the 1st quadrant, this is the 2nd quadrant, this is the 3rd quadrant, this is the 4th quadrant. Okay, if you guys don't remember. Okay. Sine is -5 or 4 over 5, right? Well, sine is going to be y over r, right? Y over r. So my y value is 4. My r value is 5. But since I am in my negative y-axis, right? That's going to be negative. That's why it's -4/5. Cool? So what is this side here? What can we do if you guys don't know that it's going to be a 3, 4, 5 triangle? What can we do? What can we do to figure out that value? Use the Pythagorean theorem, okay? We can use the Pythagorean theorem if you guys don't know the special right triangles, right? So you can go -4 squared plus x squared equals r squared, which is 5 squared. -4 squared is 16 plus x squared equals 25. Subtract 16 on both sides. X squared equals 9. X would equal 3. Right? So that's 3. Or class, just know your special right triangles in terms of the sides. There's 3, 4, 5. There is 5, 12, 13. There is, so let's write it down as a list. 3, 4, 5. There's 5, 12, 13. There is 8, 15, 17. There's 7, 24, 25. And any multiples of these. Okay. All right. Okay. So from this triangle, can we figure out all 6? All 6 trig functions? Yes. Do we have to go over them? No? Yeah. Just saying it, I'm just going to say it. Okay, I'm not going to write it down. Sine is -4 over 5. Cosine is y or x over r, so that's 3/5. Tangent is y over r, so that's -4/3. Cosecant is r over y, which is -5/4. Secant is r over x, which is 5/3. And the last one, cotangent is x over y, which is -3/4. Right? And that would be your answer. Cool? Now notice that this example here, it says in quadrant 4, right? So you're given a specific quadrant to draw your reference triangle in. This one in number 2, you kind of got to think a little bit more. Okay? I'm still going to draw, I should put it in a different color. Draw a graph. Okay? It says cotangent is +1/4 and the sine is negative, right? pick one of these, pick one of the information, right? And narrow down what quadrant it's in. Okay, I'm gonna pick this one first. Sine is negative. What quadrant is sine negative? Let's think about it though. Before you flip through your notes, right? And try to become a machine and memorize your notes, right? If sine, which is x over r, correct? Or I'm sorry, y over r, right? Is negative. And I know for a fact that r is always positive because it's a radius, right? It's the radius. So that means that my y needs to be negative, right? So it's either the third quadrant or not the second, because my y needs to be negative. So it's third or fourth, right? So it's either this quadrant or this quadrant that I'm talking about, correct? Now, looking at this piece of information, cotangent is 1/4, positive 1/4. So between the third and the fourth quadrant, cotangent, which is x over y, needs to be positive, right? I already know my y is negative. Therefore, my x needs to be negative as well, right? In order for my cotangent to be positive, negative over negative equals positive. So it needs to be the third quadrant. That makes sense? Do we understand 3 and 4? Yeah, sine is negative, right? Sine, which is y over r. So in order for this to be a negative number, my r is always positive. I know that for a fact, right? So my y needs to be negative in order for this to be less than 0, right? So if my y is negative, I know in my coordinate plane, y being negative, that's my third or my fourth quadrant, right? Cotangent, which is x over y, needs to be positive 1/4, right? Honestly, the 1/4 doesn't really matter right now. Okay, it needs to be positive, right? But I already know from this that my y is negative. That has to make my x negative in order for this to be positive, right? Negative divided by a negative is a positive. So which one has my x being negative? Which quadrant has my x being negative and my y being negative? Negative, negative, that's my third. Okay? So here is my reference triangle. That's theta. And my cotangent is 1/4. So that's my x over y. That's both negative, right? Because I'm in my third quadrant. Yeah. So now we have to use the Pythagorean theorem to figure out my r. Okay. So 1 squared plus, or negative 1 squared plus negative 4 squared equals r squared. Negative 1 squared is 1 plus negative 4 squared is 16 equals r squared. That's 17 equals r squared. So r is going to equal the square root of 17. All right. Okay. Questions? I cannot. Yeah. We're going to go through the 6 trig functions. Sine, cosine, tangent. Let's do these 3 first. Okay. So sine of theta is going to be y over r, which is negative 4 over square root of 17, right? Yeah. But I cannot have a square root in my bottom, on my denominator. Okay. So I need to multiply this by square root of 17 over square root of 17, essentially making negative 4 over square root of 17 be negative 4 square root of 17 over 17. Okay. Cosine of theta is x over r, which is negative 1 over square root of 17. Doing the same math, right? Same reasoning. I cannot have a square root in my denominator, making this negative square root of 17 over 17. Okay. Tangent, which is y over x, is positive 4, right? Negative 4 over negative 1, which is positive 4. Okay. I got 3 questions on these 3. Now I'm kind of done with my triangle. Okay. Because for the next 3, I'm just going to take the reciprocals. All right. So cosecant of theta, secant of theta, and cotangent of theta. You guys can't see that. Yeah. Cotangent is already given to us up here in my problem. Okay. Which equals 1 over 4, which is the reciprocal of 4 if you want to check your work. Cool. Cosecant and secant. I'm going to throw a question out there. Is it easier for me to take the reciprocal? Cosecant is the reciprocal of sine. So I know I'm going to flip, right? Take the reciprocal of sine. Is it easier for me to take the reciprocal of this guy or to take the reciprocal of this guy? The red or the blue? The blue. Okay. It's always going to be the blue, right? Because the square root is in my denominator. And when I take the reciprocal, what happens? It puts it in my numerator, right? So I don't have to rationalize the denominator anymore. Okay. This guy, flipping this over, that's negative square root of 17 over 1, which is just negative square root of 17. Or negative square root of 17. Yeah. Okay. Cool. Yeah. Questions? And that's the lesson for today.